Okay, guys. Let's go ahead and look at this graph. All right, guys, so the first one, that's a cubic. So we have that in our mind. Where is the center point shifted on that first one? Left 2 and up 1. Okay, is that in the area that we're actually going to graph? Yes, okay. Left 2, up 1. So I know that point is a part of it. I need to start when x is at -1. You can plug that in to figure it out. You can go with the shape that you know of a cubic graph. Either way is fine. You should get the point -1, 2. And then also we know this point -3, 0. Are we okay with that sort of shape happening? Again, that shifting that -2, 1 and recognizing that that's in the window I'm graphing. You can use your parent graph and transformations a little easier from there, okay? It's hard if that center point isn't in what you're actually graphing, because then you don't have that to go from. But that's your first section. And guys, go ahead, close your laptops. We don't need them right now, okay? All right, the middle one is just a line. So if I think about where it's -1, that'd be -2 plus 3, -1, 1 would be an open circle. You can count your slope, you can plug in, you can use your y-intercept, whatever you want to do. Get all the way over here. That's supposed to be a straight line. We'll pretend that my line is straight. Does that make sense? Goes through a y-intercept of 3, or you can find those endpoints and connect them since it's just a line. All right, then the last one being a square root. We've also got a reflection going on. So that negative out in front, I know I need to flip over the x-axis. And then where am I shifting? Up, down, left, right. Right 1, up 1. So if I think about that, right 1, up 1. That one's filled in. We know it got reflected across the x-axis. So this point is a part of it. 1, 2, 3, 4. This point is a part of it. Again, I'm just basing that. Wow, that's a terrible drawing. Off of the parent graph that I know. You can certainly plug in points if you need it to find where they are. Plug in things bigger than 1 that you can actually take the square root of. Okay. How'd we do on the piecewise? Pretty okay? We're getting there. We'll keep practicing them. Okay. All right, guys. Questions before we jump into notes? Okay. Notes today are all about domain algebraically. All right, domain, is that x or y values? X values, okay, we know that. When we're dealing with domain algebraically, there's really just 2 things you have to worry about, 2 things that will cause restrictions on your domain. So those 2 things are denominators of fractions. Denominator of a fraction. Because what can our denominator never equal?
0.
Yeah, we cannot divide by 0. So denominator of a fraction cannot equal 0. The other thing you have to look for that might cause some sort of restriction on your domain is an even root. Usually we see square roots, but like 4th root, 6th root, 8th root, those would all also cause restrictions. But really you're thinking about square roots for the most part. What can't we take the square root of? Negative numbers. What do we get if we take the square root of a negative? Yeah, imaginary. So if you see an even root, what's under there needs to be greater than or equal to 0, because we cannot have a negative number under there. If the problem you're dealing with doesn't have a fraction and doesn't have a square root, the domain will always be all real numbers then. So just look for those things. So we are just going to do a bunch of different examples of writing the domain in interval notation in all sorts of different scenarios here. We'll start easy and kind of work our way up. All right, our first function, we have 5 over x plus 3. All right, do I have a fraction? Yes. Do I have a square root? No. Every time you are just asking yourself those two questions, okay? I have a fraction. So the denominator cannot equal 0. That's what I need to solve. All right. Simple algebra here. This means x cannot equal -3. So how do I write that as domain and interval notation? Yeah, go ahead, Judy. Good. And what's on the -3s? Like parentheses or brackets? Yes. Okay, good. So -infinity, comma, -3 with a parenthesis or soft bracket. Union, parenthesis again, -3 to positive infinity. That parenthesis or soft bracket means you're skipping over that value. It is not included. All right, you guys try this one. F of x is x squared plus 5 over 2x minus 4. Check with your neighbor. Do you have the same thing? So we get x cannot be 2. So -infinity to 2, 2 to infinity. Yeah. Okay. So again, that's very much level 1. Those are easy ones. Add a little. All right, f of x equals square root of x plus 4. We'll do this one together. Troubles? We good? All right, guys, this one, we don't have a fraction, but we do have a square root. We cannot take the square root of negative numbers. So you take what is under that square root, the x plus 4, and say that needs to be greater than or equal to 0. We can take the square root of 0. It's just 0, okay? And then you just solve this inequality. Again, this is a simple inequality to solve. I can just move the 4. So x is greater than or equal to negative 4. And again, we need to write that in interval notation. So what do we think? Parenthesis or bracket this time? Bracket, because we're including the negative 4. So we're going to say bracket negative 4 to infinity. Okay, because it's everything bigger than negative 4, including the negative 4. Guys, stop me if you have questions, okay? Otherwise, I'll just keep cruising here. Okay, you guys try this one. Add a little twist for you, see if you can figure it out. 2x over the square root of x minus 5. That's your function this time. It's a little different than the one we did together. All right, guys. Let's see how we did. So this one, it has a square root, obviously, but it also has a fraction. Okay, so we have to combine those two rules. So normally you would take what's under the square root, this x minus 5, and say that needs to be greater than or equal to 0. Do I want that to equal 0? No. So instead of greater than or equal to 0, eraser is huge. We are just going to say x minus 5 is greater than 0. Does that make sense how that's combining the two rules together? Okay. All right, so just be careful when you see that. So again, basic inequality then, x is greater than 5. So we would use parenthesis 5 to infinity. All right, questions so far? Okay. They're going to get a little trickier now. Let's say f of x is equal to the square root of x squared minus 4. So something you might be tempted to do, you see an x squared and you see a 4 and you're like, well, can't I just take the square root of both of those things? Like, it doesn't work that way. It only works if it was like x minus 2 quantity squared. You could take the square root of that, but you cannot take the square root of individual terms. Like, think about it with numbers if your brain isn't liking that. What about, let's say, the square root of 9 plus 4? That's the square root of 13. It is not 5, right? We see it? Yes. Okay, that's good. You always need just normal numbers to figure that out. It's not just someone telling you can't do it.
Wait, so you can't factor it?
You can definitely factor it, yes, but it doesn't factor into like a perfect square. But yes, you should factor. So we'll start like we did the other one. We'll take this x squared minus 4 and say that has to be greater than or equal to 0. We're okay with that? Under a square root, set it greater than or equal to 0. It's in the denominator. Okay. This is not as easy to solve as the other inequalities you've been doing. You can't just move the 4 and take the square root. Like, that's not, once you have x squared, that is not how the inequality is going to work. What we're going to do is factor this. So what does this factor into? Okay. All right, and then we are going to make a number line with this. What do we think the two numbers on my number line should be? Any guesses? Yeah, and make sure you put them in order. The -2 has to come first. Okay, we are going to test regions of this number line, and then I'll explain what all these pluses and minuses mean once we do that, okay? I need to pick a number to plug in that's easy to plug in. I'm going to use 0 because that's very easy to plug in. 0 lives in this part of the number line, so this is the region I'm testing first, okay? So to plug it in here, what is 0 plus 2? 2, okay, a positive number. What about 0 minus 2? Negative number, right? What we care about is the product of those two factors. So if I multiply those together, do I get a positive or a negative? Negative. That means that region of the number line is negative. Any value I plug in between here, I plug it in up here, I will get a negative answer in the end. Okay? You can plug in other numbers, or we can use what we know about multiplicity and know that my number line will alternate. As long as my factors don't have even multiplicity, so like an exponent up here, like a 2 or a 4, your number line will alternate. So since this is negative, what will this be? Positive, and same on the other end. You don't have to write this part, but the other way you can think about this is if we were actually graphing this quadratic, you would have x-intercepts at -2 and a +2. It's positive, so like general shape, would you agree that's the graph of that quadratic? Okay, so it's asking you, when is this quadratic greater than 0? When is it above the x-axis? In between here, it's below the x-axis. The ends are where it's above the x-axis, okay? So it all connects to the graph. And then writing your final answer, we want to know greater than or equal to 0. So that's the positive pieces of my number line that I found, right, where the little pluses were. Or equal to, so I can include -2 and the 2. So your answer would be -infinity to -2 bracket, union bracket 2 to infinity. Okay. We're going to do a bunch of these. I know that's new for you guys. But any questions? Any piece of the number line that you're like, where are we? All right, let's just keep trying these. And we'll get there. Okay, you guys try this next one here. Let's say our function is the square root of x squared minus 2x. Okay. So just like we did the last one, factoring all of that. So this is great. You can't plug into this. So what else? And that makes it great. So one there is the yeah, so positive.
I think so. So what happens? Janice like small. Have you ever done that? It works. I promise it works. Thanks. Oh, yeah.
Okay, good so far. So now we're
Every Christmas morning is the beach out there.
sometimes that's
Are you gonna want to?
okay, guys, walking around, we were doing great. From here, you need to factor. If you see x squared or higher degree, factor. Don't divide away an x, you'll lose solution. So always factor from here. So we'd have x times x minus 2. So the 2 points on my number line are 0 and positive 2. 0 comes from that factor of just x. I can't plug in a 0 since that's one of my points. So it looks like a lot of you guys plugged in 1, which is good. That's easy. If you're like 17 is my favorite number, like, yes, you can do that. It's just sometimes more complicated to plug in. It doesn't matter other than it can't be these the points we have labeled. So 1 would give me a positive times a negative, which is negative. This will alternate. I want the positive parts. So negative infinity to 0, union bracket 2 to infinity. Okay. All right, let's try again. All right, comboing a few things for you here. Let's see how you do. Do you notice my square root, how it doesn't have x squared in it? It's just an x. So do we need a number line for this one? No, you do not. Okay. Just making sure we see that.
I'm sorry, it's not my fault.
Give the hiccups.
I'm like trying to do that. I can't promise you guys. I said, why don't you just look at the thing? That's the thing. That's the thing. I was thinking. Don't laugh at me. It's not nice. Oh God, let me focus. You don't laughing at me. Oh yeah, no, it's not.
I'm going to start going through it up here, guys, if you're ready. You have two separate things to think about. So that numerator, the square root part, has to stay positive. The denominator cannot be 0.
I'm in next week.
Well, we care about it because there's a square root in it. Like, even think about this one. No fraction, but we still cared. Like, essentially, this is the numerator of a fraction. Yeah, so we care about that because of the square root. This, because we don't want it to equal 0. Okay. So we can factor. All right, are you guys getting to this point where x can't be plus or minus 2, and then also x has to be greater than or equal to negative 4? Like, those two parts make sense. You then have to put those together in an answer, okay? If you can just see this and write your answer, awesome, do that. If you need a number line as a visual only, not as a number line test, but if you need to like draw what this is saying before you write it, do that, that's fine. What I mean by that is we could say, here's negative 4, negative 2, and 2. I know it's not those things, but it is this and everything to the right. If that visual helps you go, okay, bracket, negative 4, 2. Sorry, that's a negative 2. Union, negative 2 to 2. Union 2 to infinity. Totally optional, but if that helps you write your answer, draw the picture, okay? It's not necessary for solving.
Does it not go to negative?
Does it what? I'm sorry.
Not go to negative.
Nope, because of this piece right here, since it has to be greater than or equal to -4, it can't be anything on the left side of that. Yep. Other questions on that, guys?
But it goes to positive.
It does. Because if we look at just this piece, that would be -4 all the way to infinity, and then we just have to skip over these two values. Okay?
So
It's like a lot of, it's like I get this piece, but putting them
we were
together.
just another part of the numerator or denominator.
Okay.
That it would be negative infinity.
Yeah, it'd be -infinity, -2, -2 to
But then
2.
the numerator is kind of like 2.
Yes. Yep, exactly. All right, guys, we're going to try a few more, and then we'll practice. All right, guys, tell me the domain on that. 3x squared minus 7x plus 10. Oh, I'm sorry, the wires. I really need to do something about those wires. I feel like they're getting worse, and I don't know how.
I think I'm right. I'm probably wrong though. I think I'm right, but I'm probably wrong. But I might think I'm right. I'm usually wrong.
No, failed your confidence.
No, what's the news?
Guys, is anybody like trying to factor this or do work on it? Do we need to? No. Remember, ask yourself, is there a square root? Nope. Is there a fraction? Nope. So what is your domain?
Oh, right.
All real numbers, yes. You get in the groove of like having to do all this work and forget that some of them are just easy.
So no fraction or square root.
Is all real numbers. Yeah, those are the only two things that are going to cause restrictions for you. So, hold on, let me make up a good one.
You just got the I remember, how do you not remember the fact?
All right, guys, try this one. You do have to do some work on this one, okay?
What else can you Oh, fine.
Keep breathing.
No, you're okay. I'm trying to. It's not 1, 2. And it's not 1, so. I'll let them talk. No, you can't do that. I'll go to complete school. Oh no, you can't do that.
Oh, guys, how about I give you one that actually factors?
Oh.
I'm so sorry, guys. I feel like it didn't, because it would have been 16 and 7. Yeah. Let's make that a 4. Minus 4. Sorry, guys. That's what happens when I make up questions on the fly. Try again on your factoring. It should be much happier.
No. 2 and 2.
It's not multiplying to 4. What is it multiplying to?
Oh, no. Multiplying.
There's a leading coefficient. So multiplies to -8.
Oh yeah, it's 1 and 1. It's 1 and 1. It's 4 and -1.
Are you just doing guess and check, or are you
No,
regrouping?
it's 4 like because 4 times 2 is 8 minus 1 is 7.
Yes.
Oh, you did it that way. I was trying to do it the other way.
What is the other way?
No, it's the other way, like where the 4 is on the side of the.
There's so many ways.
Oh. None of this can equal. Oh, this is better than equal this one. You. So it's just negative. Right. Yeah, but it can be less. Oh yeah. Good point. No, but then how would that work? How would you get how does -4 work? Because it would be greater than
You need a number line for this one, guys.
what?
We did a few problems without a number line. Go back to your number line, okay?
No, but like I'm right. I'm literally right. No, I'm right. No, you're gonna see that always. No, you're gonna see that I'm right. You're gonna see that I'm right. Then you're gonna see that I'm right. No, you're gonna see that I'm right. No, I make sense. I make more sense than you. That's not true. Rational is normal. I mean, both go that way. Yeah, so we come from -4. I know, but if you're right, it can't be less than 1/2. Just go on. Just do your own math. I don't care. I don't need you. I don't need you in my life. So don't fall in.
You got your factors, right?
You're gonna see that I'm right. I know this goes here. Why? Why? Because this one's not old. No, this does work. It does work. I'm right. You're wrong. You're wrong. Okay, I'm right. You're wrong. You're wrong. I don't want to. I know. That's all the work.
Whole row.
I don't know because I'm right and you're wrong. This is why you're because I'm right and you're wrong. Nothing. I'm gonna be right. Okay, I just saw people think I'm wrong. People are going to think I'm wrong. And whenever I think I'm wrong, I'm right. Does that make sense? I like that.
Your number is straight. There's 2 boards. Just straight.
Everything came back. You jinxed me. They hurt a lot.
Yes.
No, I was right there. I was right there. So I did the number line. That's what What? I made you. I don't understand your number line. I don't understand you. Whatever. Neither of us were right. That's not true. You said it was greater than 1.5. Yeah, it is greater.
All right. Again, apologies for the non-factoring question to begin with. So when you factor, guess and check, grouping, boxes, whatever, as long as you can actually factor. Oh, and I did it backwards. Let's make my signs work. There we go. No, I did the exact same thing again, didn't I?
In my head now, I can't stop.
There, finally. So on my number line, I've got -4. Hey guys, up here, let me just go through it. I've got -4 1/2. We plug in whatever you want other than -4 1/2. I will test 0. That gives me a negative and a positive. Overall, that's negative. Positive. So I want greater than or equal to 0. I want those parts. So negative infinity to -4, union 1/2 infinity. Are we catching on to the number line part? Sorry, let me move that up a little bit for you guys.
How many problems are
I don't know. Let's do another one.
How about
One more.
J?
One more.
That's so rude. You're rude. Oh my gosh, I want to try it one.
All right. Oh, make it x squared. I changed my mind. X cubed minus x squared. Yeah, because I want to show you something on the number line. All right, guys, try number 10. Last one in your notes. You can do it.
So that's greater than or equal to 0. No, I can put it inside head. We're so chaotic. It can't be equal to 0 because it's like non-zero. You know what I mean? That was just for show. Like, actually, I forgot to think about it. I don't know where we're supposed to go. I don't know.
You don't know what to do?
I probably, if I looked at it for a long time, I would figure it out.
Okay, square root, right?
Yeah.
So what's under it can't be negative.
Yeah.
Guys, do we want this one to equal 0?
No. No.
No, it's in the denominator, so we just want to say greater than 0. Then you factor, and use the number line to solve from there, okay? Factor, number line from there. Okay. Set up your number line.
X squared is greater than 0, so X equals greater.
No, factor and a number line.
Oh, number.
Yes. Right? Like over there on the left one, we didn't say 2x minus 1 is greater than 0 and x plus 4, right?
Yes.
Factor, number line.
Yeah.
I added multiplicity on this one, guys, so think about that on your number line. Okay. I know, you're like, what is multiplicity? I like the facial expression. Gives me a lot of info.
I think we're right. I think we're right, actually. I think we're so right. I think we're right, but I'm not going to write that one. No, I wrote it down. It's writing it down. I'm so confident that I'm like, no, shut up. Shut up.
What does that mean? Okay. All right, guys, let's look up here. Is everybody getting to this point?
No, yes it is.
Yeah, tell me yes. You actually got it. Okay. From here, you still start by testing a number. I can't use 0 and I can't use 1. What do you guys want to use? 1/2? I mean, sure. What? Just for fun? I was going to use like 2, but I mean, we can use fractions.
2.
2?
How are you going to get 2 in the middle?
2 is over here.
Well, I thought we were trying to do the middle.
You don't have to do the middle. You can pick any number.
Fine, 2.
All right, I'm using 2, guys. Plug a 2 in. What's 2 squared?
4.
Okay, positive, right? What about 2 minus 1? Also positive. So what is this end of my number line? Positive. Okay. This is where it gets interesting. We now have multiplicity to deal with. So multiplicity, some of you guys don't write this down. You might remember it from graphing polynomials last year. If you had like x plus 1 squared and x minus 4 squared, like 1, 2, 3, 4. You had like the bouncing. So you remember that, where it would like touch the x-axis and bounce off? Okay, so if you look at that, it was above the x-axis, bounced off, and is still above the x-axis, right? Even multiplicity means it's going to do the same thing on both sides. Ooh, too much cookie. So let's figure out what's happening around the 0. This is positive. Does the 1 have multiplicity? Like, did this factor have multiplicity? No. So if it's positive on this side, what will it be on this side? Negative. That will still alternate, okay? Because there's no multiplicity around that 0.
Oh, I get it.
Now this guy, even multiplicity, right? We see how that's connected? Okay. Bounces. It's negative on one side. What is it going to be on the other side? Negative. It will match on either side when it has even multiplicity. This. Okay. Then we still have to answer the question, guys. You're not done at the number line. Where is it greater than 0? Isn't this positive? Just that little section. These weren't included, so your answer is 1 to infinity.
No, this is one thing I got wrong.
Okay, let's pause there for a second. Yes. Then it still will alternate. So graphically, odd multiplicity, like if I have x minus 2 cubed, that is a point of inflection. So it changes concavity, but it still goes like above to below the x-axis. Yep, good question. So it's only even multiplicity that impacts the number line situation. Other questions on that one? Okay. Okay. All right. We have time today, guys. We're going to play what's called the bluffing game. So I need you to reach around and grab your whiteboard out of your desk. Hopefully there's a marker somewhere. If not, we have some up front.
Do you have extra markers?
Yes, there are some up here. All right, we have 3 teams going on. Let's see. 2, 7, 8. Okay, you guys are team door. You guys are team middle. You guys are team window. Super complicated names, I know. Okay, so the bluffing game. Listen up so I can explain how this works. I'll put a question on the board. Everybody does it on their whiteboard. And then I'll pick a team to answer. So I'll say middle team. If you think you have it right, stand up. However many people are standing up is how many points the question is worth. So it's called the bluffing game because maybe you don't have it right or don't know how to do it. You can still stand up. But if you're standing, you're eligible for me to call on you to answer it. Does that make sense? So like you want everyone to stand up because then it's worth the most points. But you might be pretending that you know what you're doing when really you don't know what you're doing, okay? All right, let's try one. We'll start simpler. We'll start with like a round of fairly easy domain ones, and then we'll get creative. All right, and you don't know who I'm calling on. And if a team misses it, another team can steal it for half of the points. Hey guys, I promise I won't like look at what's on your board and seek out the person who's bluffing, okay? I won't try to catch you bluffing. It'll be random who I pick. Consensus reached and you're done. Yeah. Okay, don't show me yet. Let's go team window. You guys have the fewest people, so we'll let you guys go first. So if you think you have it or you want to pretend you have it, stand up. You want to stand up because then it's worth more points. 2, 3. Okay, all 7 points. And then yes, you got it. All right, window team gets 7 points. Guys, the answer was negative infinity to negative 3, union negative 3 to 0, union 0 to infinity. Yay? Everybody? Oh, sure. All right, so denominator, right? I don't want that denominator to be 0. And then I just factored out an x and thought through, okay, x cannot be 0 or -3. And so then writing it negative infinity, -3, -3, 0, 0. That part is the part that's... So you don't need a number line to answer this one. So, okay, let's visualize it with a number line. It's not -3 and it's not 0. Do you see how there are 3 sections? Yep, so negative infinity to -3. -3 to 0, 0. Yeah, does that help?
Yes.
Okay. All right, let's try again. Okay, let's say we've got x over square root of x plus 3. Again, we're starting with the easier ones, and then they'll get trickier. Are we ready, guys? No. Ready? Middle, you seem ready. Let's do middle. So stand up. Don't show me your board. Just stand up, and then I'll pick. Okay. Okay, good job. All right, guys, the answer to this one, -3 to infinity. It's in the denominator. Do we want it to equal 0? Does that make sense, though? Okay. All right. Good, it wasn't you guys' turn. All right, let's try again.
Great job.
Are we ready, guys? Score team, stand up. Bruce, are you participating? Okay. They have the most people, guys, so our teams are slightly unfair here. But. Okay, you had to think about two parts on this one. So that numerator needs to be greater than or equal to 0. And that denominator cannot equal 0. So x has to be greater than or equal to -1, but it also cannot equal 3. So it is bracket -1 to 3, union 3 to infinity. All right, so far so good? All right, that was our easy round. Now let's make them a little trickier. All right, guys, try this one. And I could call on anybody now. We don't know who it'll be.
Oh, were you before checking to see if you were right?
No, I mean any team. Like that last one, I was going to pick the 4 because they. That's the question, isn't it? You don't know how you got there. This one is different. Like, can you use what we've been doing and apply it? Think about all of your rules. How do you put it together in this one? You're like, okay, now I get it, but yeah. Okay, let's go middle. Stand up, middle. Sorry, I know, I'm neglecting you. 4, 5. Okay. All right, so it's now worth 4 points. Fastest hand up. Go. I thought you were. Okay, let's come over here.
No, I scared a bit. No, we had it right. I'm so sorry.
Weirdly, it was the same answer as the last question, which was completely unintentional. All right. Let's go through this because I think we have some questions. You guys had a lot of the pieces, but didn't have the entire thing put together. So there's two pieces here. We have a square root, right? So we still have to think about that square root part. So x plus 1 has to be greater than or equal to 0, that tiny little piece. You also have to think about the square root of x plus 1 minus 2 cannot equal 0. All of that has to happen. Okay, so we know x has to be greater than or equal to negative 1. That's the piece that I think a lot of people forgot. The second piece, I was impressed a lot of you got this. So if we solve this, can't equal 2, square both sides, we get x cannot equal 3. Okay, that's what would make your entire denominator 0, and we can't have that. We can't divide by 0. We also cannot have a negative in that little square root piece. So your answer is bracket negative 1 to 3, parenthesis, union 3 to infinity. Did anybody else actually have that one? Or was it, yes? Okay, we had a few more get it? All right, good job, guys. Okay. Let's do one more. I know that's not equal questions for everyone, but I want to pass back your quizzes too, so. We'll do this one differently.
Why?
Okay, ready, go. This one is worth like lots of points. I don't know who's gonna get it. We'll see. Since it's our last one.
Yeah, I would. So number This feels right. This feels right. It feels right.
I know, time is speeding away and I want to get this fast. All right, guys. Speediness. You can do it. I got it. Okay, points. I don't know what we're doing for this. Every team stand up, and then I'll pick someone from each team, and we'll see. Oh, no one? Oh, I don't know. I mean, it looks like they got it. Let's see. I looked at the wrong thing. You were close.
Oh, it's because the negative 2. Because that we had magic and This should have been -2. No. We almost had it.
We maybe shouldn't have been standing yet. All right. I don't know who got the most points. Middle got it right though, so yay, team middle. We ran out of time here, guys. When you do your number line on this one, if I test 0, I get positive, positive, negative. That's negative. Multiplicity tells me that's negative. Positive, positive. Your answer should have been negative infinity to -2 parenthesis union parenthesis 4 to infinity. Okay, I'll leave that up there. All right, guys. Delta Vet is posted, and let me get these passed out. I might just be yelling names.
Yeah, I knew it.
I forgot that.
I can do it.
Where's Dana? Okay. If you're stuck on anything, okay? Otherwise, Delta Math, and then we have one more section of notes in this unit. Okay? Question or brain labs? Communication matters so much in here, I know. Yeah. So this, you didn't bring this part right so the F of whatever. That's this one.
Why would it be
So that's what this is. This is just X. Exactly. Okay. So that one's not relevant. I dropped the two crap. So it's just all
Is there gonna be geometry stuff on the SAT? No.
This is really
I know that, but now I know that.
Yeah, now you know that from my mug.
Sine or cosine is it's tangent.
Yep.
I, but so